14.6 Production and use of ultrasound in diagnosis. C. Understand the meaning of specific acoustic impedance and its importance to the intensity reflection coefficient at the boundary. Question 1. What is acoustic impedance? Question 2. What the relationship between the reflected intensity and the acoustic impedance? Question 3. Explain why in the ultrasound scanning, bone shows up well, but it is difficult to see different soft tissues, and why the patient's skin is smeared with gel before a scan. So what is acoustic impedance? The acoustic impedance, labeled by capital Z, is an acoustic property of a material, which determines the intensity of sound that is reflected at the boundary. Acoustic impedance is defined as the expression acoustic impedance equals to density times speed of sound, which in symbols is Z equals to log C, where log is the density of the material, and C is the speed of sound in that material. Here is the table showing values of log, C, and Z for some material that are important in medical ultrasonography. For example, the density of air is 1.3 kilograms per cubic meter, and the speed of sound in air is 330 meters per second. So 1.3 times 330 gives the acoustic impedance of air, which is 0.00004. Note that the unit is 10 to the 6th kilograms per meter squared per second. Now that we know what is acoustic impedance, we are going to consider the relationship between the reflected intensities and the acoustic impedance. Qualitatively speaking, when an ultrasound beam reaches the boundary between two materials, the greater the difference in acoustic impedances, the greater the reflected fraction of the ultrasound waves, which is very intuitive and fits our common sense. The more similar the two materials are, the less intensities will be reflected at the boundary between them. And if the two materials are exactly identical, there will be no reflection. And quantitatively speaking, for normal incidence, which means the angle of incidence is below the critical angle of total eternal reflection, the ratio of the reflected intensity I sub r to the incidence intensity I sub 0 is given by this equation. I sub r over I sub 0 equals to the square of the difference of Z sub 2 and Z sub 1 over the square of the sum of Z sub 2 and Z sub 1. Or we can rewrite the right part as this: the square of everything in the parentheses, where Z sub 2 and Z sub 1 is the acoustic impedances of the two materials, and the ratio I sub r over I sub 0 indicates the fraction of the intensity of the beam that is reflected, and the right part of the equation as a whole is the intensity reflection coefficient. Now that we know the relationship between the acoustic impedances and the reflected intensities of ultrasound waves, we are able to explain why in the ultrasound scanning there are some facts like this. The first one, why bone shows up well in ultrasound scanning. That's because if we look up the acoustic impedance value of bone in the previous table, here is bone. The average value of it is 6.40, and we know that the bone is always surrounded by soft tissues, and the average acoustic impedance of soft tissues is 1.63, and the difference between them is relatively big. So there will be a large fraction of intensities of ultrasound reflected at the boundary between bone and soft tissues, and then the ultrasound reflected will be detected and analyzed to produce a picture showing the boundary, which has the same shape of the bone. And that's why bone shows up well. But why it is difficult to see different soft tissues? The same mechanism. So suddenly we look up the acoustic impedance value of soft tissues, and we've already known the average value is 1.63. And now let's look at a specific soft tissue, say the fat. The value of it is 1.34. And here is another specific soft tissue, muscle. The value of it is 1.71. And we can see these values are relatively close together. The difference is relatively small. So very little intensities will be reflected at a boundary between soft tissues, including fat, muscle, and blood. So it's difficult to see different soft tissues in an ultrasound scanning. And another fact you must know from your experience about ultrasound scanning is the patient's skin is smeared with gel before scan. And now I guess you can explain why. Secondly, to look up the acoustic impedance value of skin. Skin as a soft tissue, the acoustic impedance value of it is about 1.63. And we know that our skin is in contact with air, and the value of air we've seen before is 0.00004. And the difference between the two values is so big that when ultrasound comes to the patient's skin, most of it will be reflected back before it enters the body of the patient. Let me give you an actual value. About 99.95% of the ultrasound will be reflected back. And this is a very serious problem for an ultrasound scan. To overcome this, the patient is smeared with a gel whose acoustic impedance is close to that of skin. And then the transducer is closely pressed on the gel. So the ultrasound produced by the transducer gets to the boundary between the gel and the skin. The percentage of the intensity reflected is very small. Most of it gets into the body of the patient. That's what we need for a successful ultrasound scan.